When you ask a cloud-based AI to identify a plant, your data travels thousands of miles to a massive server farm and back. That half-second delay is the difference between a tool and a toy. But Meta just changed the game by shrinking the brain. The era of giant models is hitting a wall. We're talking about billions of dollars in electricity just to run a chatbot. The solution isn't a bigger server, it's a smaller architecture. Meta's new strategy is called scaling down. Instead of 1 trillion parameters, they're packing high intelligence models into just 1 or 3 billion, and it's happening right on your glasses.
For years, the industry thought bigger is better. GPT-4 and Llama 3 were massive behemoths, but Meta realized that for wearables, size is the enemy of utility. Enter Llama 3.2. These are the first models designed from the ground up to live on mobile hardware. They aren't just smaller versions, they are re-engineered for efficiency. This shift is genuinely brilliant because it solves the two biggest problems in AI, latency and privacy. If the data never leaves your device, the speed is instant and the security is absolute. Imagine walking through a grocery store and your glasses tell you exactly which ingredients fit your diet in real time. No loading spinners, no searching the web, just instant context. This is multimodal on-device AI. It means the model can see what you see and hear what you hear without a single byte of video ever touching a server. But to make this work, engineers had to solve a massive physics problem. How do you run a brain-sized model on a battery-sized budget? The hardware bottleneck is real. Your phone's NPU, or neural processing unit, is the secret hero here. It's a specialized part of the chip designed only for AI math. Unlike a CPU that handles everything, the NPU is built for one thing: matrix multiplication. It's what allows Meta to run these models without melting your pocket. But even with an NPU, you can't just shove a massive model onto a pair of glasses. You have to use a technique called quantization. This is where the engineering gets wild. Quantization is basically rounding off the numbers. Instead of using high-precision math, the AI uses good enough math that takes up 75% less space. Then there's knowledge distillation. Think of it like a giant teacher model training a tiny student model to have all the same vibes but none of the bulk. The result? A model that can run at 30 tokens per second on a device that fits in your hand. But wait until you see what happens when we put this on your face. To understand the shift, we have to look at the Ray-Ban Meta glasses. They don't have a screen, they have eyes. And now those eyes have a local brain. Meta's context-aware vision means the glasses aren't just taking photos. They are constantly analyzing the world to understand where you are and what you're doing. But here's the kicker. Doing this locally means the glasses can respond to your environment faster than you can blink. It's the end of the uploading bar.
The trade-off is reasoning. A 3 billion parameter model isn't going to solve a complex physics equation. It's built for fast thinking, not deep thinking. Think of it like the difference between a library and a reflex. The cloud is the library. It knows everything. The local AI is the reflex. It acts immediately. Meta's clever trick is a hybrid approach. The local model handles the now, and if things get too complex, it quietly asks the cloud for help in the background.
This requires a massive shift in how we build apps. Developers are no longer just calling an API. They're managing local memory and NPU cycles. Memory is the biggest bottleneck. These models need to stay resident in RAM to be fast, but smart glasses only have a few gigabytes to spare. To fix this, Meta uses 4-bit quantization. It's like turning a high-definition movie into a super-efficient vector graphic. You lose some detail, but the story stays the same.
Some skeptics say local AI will always be a light version of the real thing, but look at the benchmarks. Llama 3.2 3B is outperforming models 10 times its size from just 2 years ago. The secret is the training data. Meta is using synthetic data, where the giant models teach the small models by generating millions of perfect examples. It's a recursive loop of intelligence. The big models are getting smarter so they can build better small models. And that's when things get a little weird.
Because when AI is always on and always local, it stops being a tool you use and starts being a layer of your reality. It's the exocortex. It can remember everyone you've ever met, translate every sign you see, and whisper directions in your ear, all without the cloud ever knowing. But this level of power comes with a cost, and it's not a cost we're used to paying. We're talking about the total erasure of anonymity.
If everyone is wearing a camera that can run facial recognition locally, privacy as we know it is over. You can't opt out of someone else's glasses. In the past, facial recognition was hard because you needed a massive database and a fast connection. Now, you just need a 3 billion parameter model and a local list. This isn't a theory. Researchers have already shown that smart glasses can be paired with public databases to identify strangers in seconds. It's a superpower we aren't ready for. Meta is aware of this. They've built in privacy lights that turn on when the camera is recording. But as AI gets better at passive sensing, those lights might not be enough. The real challenge is social friction. How do you talk to a friend when you know their glasses are analyzing your microexpressions to see if you're lying? This is the always-on paradox. We want the benefits of a personal assistant, but we don't want to live in a world where everyone is a walking sensor node. But here's the fascinating part. The same technology that erases public anonymity might actually save our personal privacy from big tech companies. If your AI is local, your data doesn't have to be sold to advertisers. Your digital twin lives on your hardware, not in a server farm in Virginia. We are moving toward a world of sovereign AI, where you own the model, you own the weights, and you own the insights. It's a total flip of the current power dynamic. So, where does this go? In the next few years, we'll see scaling down reach its final form, AI that is invisible, instant, and inseparable from our own thoughts. The cloud won't disappear, but it will become the backend for the heavy lifting, while the local NPU becomes the primary interface for our lives. The engineering feat of shrinking these models is genuinely one of the most impressive things I've seen in a decade. It's not just a smaller model, it's a bigger world. The shift from giant models to scaling down isn't just a technical trend. It's the moment AI finally leaves the lab and enters our reality for good. We're trading the infinite knowledge of the cloud for the instant intuition of the edge. And honestly, I think it's a trade we're going to love. The question is, when everyone has a local brain in their pocket, what will we choose to do with ours? The future is local, and it's just getting started.